It begins with a large tortilla. Cut a strip from the middle where it's widest and free this long rectangle from the useless wedges that surround it. This is how we start our journey towards creating the perfect food. The hardest part is folding an angle of equal thirds, but if you folded a piece of paper into thirds for a letter or pamphlet, you know the principle. Approximate and then adjust until you reach equality. In the case of the tortilla, to get an equilateral triangle, you fold an angle rather than an edge. Be sure your folds meet at a point, one corner of a triangle. Unlike paper, this soft and delicious tortilla is forgiving, adjusting easily rather than creasing and crumpling. Continue folding one triangle on top of another. Pinch each fold to give it a crease. 10 triangles are necessary. Remove the extra. Arrange the strip of triangles into a hexagon. Note that the folds naturally want to go the same way you creased them. This will help you to arrange the overlap so that it is symmetric, woven together in the same way you would fold the flaps on top of a box to support each other. In paper, I might use 9 triangles and then a piece of tape. For tortilla, use 10 and attach the first to the last. Score the tortilla lightly with a knife to rough it up, and then use your fingers to wet it with water. The water combines with the flour in the tortilla, and by pressing the triangles firmly to one another, they are effectively glued together. Thus, a tortilla hexaflexagon is created. It can be flexed by pinching 2 triangles together and pushing in the opposite side to get a flat, 3-armed shape, then opening up the inside. However, it is imperfect, for it is not yet delicious. Luckily, there are several sophisticated tools with which to remedy this problem, the first of which is guacamole. I start with the easily spreadable ingredients, which can be folded flat into the hexaflexagon. Flex it by lifting the 3 parts with the flappy foldy creases, and fold them to the inside. Then the bottom can be opened up, and the flexagon is once again ready to be piled with delicious ingredients, the precious guacamole being stowed safely within the folds. After adding beans and cheese, your hexaflexamexagon is ready for consumption. To eat, flex only halfway and bite the delicious exposed triangular pockets of Flex-Mex perfection. As you can see, the ingredients tend to leak slightly out of the folds of the flexagon. This is expected and unavoidable, as the nature of the burrito is to be a delicious leaking mess, regardless of whether it is cylindrical or hexaflexagonal. As your next Flex-Mex project, consider the humble crane guarding her flavorful nest.
I talk to teachers about engagement. Oftentimes there's this prevailing idea that math has to be real world to be engaging. What's the solution to a boring math problem? Make it real world, quote unquote, whatever that means. And the way to make them engaging is to kind of staple on some kind of context, and kids aren't fooled. And we shouldn't think that they will be. So I don't see real world as any kind of silver bullet. And real world problems can be ruined also for students. So the idea, I guess, is to find contexts that are meaningful and familiar and realistic to students. So the Freudenthal Institute talks about how they're after realistic mathematics, not real world math. So a fairy tale or a story or some imaginative scenario can be just as real to a student as anything else. And when it comes to pure mathematics or math that can't be applied, we can still find students' experiences that are just as engaging as math that they'll put into play outside the classroom tomorrow. Asking students questions that are triggering for them and that are open and give them some agency. The question that I've used recently that I just like a lot from Malcolm Swan is, if you take any number at all, say 25, and break it up into pieces, say 10, 10, and 5, or 25 ones, or 12 twos and a 1, or whatever, and then multiply them all together. What do you have? And then what's the biggest product you could make? Is a question that has such a low bar for entry, easily understood by lots of different students, offers lots of choices in its middle, and we come back together and there's this kind of competitive investigatory edge to it where we're trying to find the largest possible product.